Great. Thanks, Dean. Armstrong Ceilings is happy to be able to sponsor the Architectural Records Sustainability Academy and also to be able to bring you this webinar. First, I'd like to extend my thanks to everyone involved in bringing this to you today. We're very happy to join you, and I also want to send my big thanks out to our expert panel of Stacy and Kirsten here today. So I'm going to kick it off with a look at our industry, the building sector. And certainly we've gone through many changes this year, as everyone has. But the fact still remains that we are at a tipping point in our chance to really make a difference as it relates to climate change. As you can see, we have a major impact on the environment with facilities that are constructed by our industry. 30% of global greenhouse gas emissions are caused by buildings. And we are also dealing with resource scarcity. Less than a third of all construction and demolition waste is recovered and reused. So we're using up valuable raw virgin materials. And we continue to build at a growing rate in cities worldwide. You can see the big numbers there. The world is currently undergoing the largest wave of urban growth in human history. More than half of the global population is now concentrated in urban areas, and by 2060, 2/3 of the expected population of 10 billion will live in cities. To accommodate this tremendous growth, we expect to add more than 2 trillion square feet of new floor area to the global building stock, which will be doubling it in area by 2060. And to put that in perspective, that is the equivalent of adding an entire New York City every month for 40 years. This new building stock must be designed differently, must be designed to meet zero net carbon standards. Buildings generate nearly 40% of annual global greenhouse gas emissions. As you can see from this chart, 28% from the building operations and 11% from materials and construction. And many key owners are now making commitments to change the course, to be carbon positive, to use low carbon solutions, to purchase clean energy, and invest in offset projects. We know we need to take action. Today, I'd like to introduce to you an open industry collaboration called Materials Can, which stands for Materials Carbon Action Network. This network was formed with 6 original partners, Skanska, Gensler, who are joining us today, Interface, Armstrong Ceilings, USG Drywall, and CertainTeed Insulation. And then we added 2 additional companies, Superior Essex and Kingspan. All are committed to lowering carbon emissions. And as you can see, the mission of this group is to drive awareness and take action on the highest impact aspect of energy consumption in the building industry. But first, we need to understand what that is. And there are 2 different types of carbon, as you can see depicted here. The first, operational carbon, refers to carbon dioxide emitted during the life of a building, emissions from heating, cooling, and lighting. Second is embodied carbon, refers to the carbon dioxide emitted during the extraction, manufacture, and transport of building materials. To date, we've had many ways, mechanisms to address operational carbon, but few to address embodied carbon. But thankfully, we'll be sharing several of the strategies for embodied carbon today. To focus a bit more on embodied carbon, it represents 1/4 of the annual building sector emissions, and it continues to grow. Globally, it's responsible for 11% of annual greenhouse gas emissions and 28% of building sector emissions. As operational energy efficiency increases, we're getting better at energy efficiency in buildings, the impact of the embodied carbon emissions in buildings will become increasingly significant. We cannot meet our climate goals without also eliminating embodied carbon emissions by 2040. And we also need to remember that climate change is not just about the effect on the environment, it also impacts people. You can see the slide from the CDC that illustrates the most significant climate change impacts. You can see the turning circle there, rising temperatures, more extreme weather events, which we've all seen, rising sea levels, and increasing carbon dioxide levels. And their effect on exposures, which you can see in the outer rings of the circle, health outcomes that can result from changes in exposures, like respiratory and cardiovascular diseases, injuries, and premature deaths related to extreme weather events, changes in the prevalence and geographical distribution of food and waterborne illnesses and other diseases, and also threats to mental health. So how can you take action on evaluating embodied carbon? We're going to walk through that. First, we're going to start with, again, the first step is understanding, and the embodied carbon is all about the life cycle, which we're going to dig into right now. It's all about the carbon dioxide emitted during all stages of a product life cycle. And this is really what comes out of what's called life cycle assessment, or LCA. It's a tool that allows us to understand the environmental impacts associated with products. I'm going to walk through a little bit overview of LCA. I'll stay at a high level, though, because you can really go deep in this subject. So let's review the 4 key stages of life cycle assessment. The first is a goal and scope definition. So as a manufacturer is looking at our products, we're working in a life cycle model, and we're looking at the first stage, which is making decisions about what should be studied and how the results of the study will be used. The second step is a life cycle inventory, or LCI. In this stage, the data is collected, modeled, and analyzed. So we're going out and getting all of the data from our manufacturing facilities or wherever it's manufactured and bringing that inventory into that LCA model. The third step is impact assessment, and this is where the analysis occurs of the ultimate effects of the life cycle inventory results. And then lastly is interpretation. This is where the data is published and made available to the public, usually in the form of an EPD, or Environmental Product Declaration. All of this is governed by ISO standards, which is the International Standard Organization, which detail how a life cycle assessment should be calculated. Here you can see the input into a product's LCA model, going through each stage of its life cycle. First, there's the birth of the product. Its raw materials become inputs into the production. Then the product is manufactured. It's using energy, water, and it's producing waste, or reusing waste, hopefully. Distribution, it's packaged and transported, it's installed in the building, and then it's used. Eventually, a product's useful life will come to an end, and a decision will have to be made on disposal. Perhaps it can be recycled. We certainly hope that's the case. Or if not, it will end up in a landfill. Depending on the product, different impacts will have more or less impact in each of the stages. For the most part, for building products, the majority of their impact occurs in that extraction, in the raw material stage, and also in the manufacturing stage. The next is, what are the outputs? So that was the input. This is what you will receive as an output of the life cycle assessment, which shows the impact on the environment. So what your product has in terms of its effect on climate, air, and water. And then you can see that embodied energy there is the one that we're really going to dig into today. And as I mentioned, all of this life cycle information is summarized, reviewed, and third-party certified in EPDs, or Environmental Product Declarations. And most manufacturers do have product-specific EPDs available. They can be rather lengthy documents, up to 18, 20 pages. And luckily, though, today we're making tremendous progress in many resources to effectively use embodied carbon information to make smart choices. Declare labels have added embodied carbon. The LEED rating system has new credits for embodied carbon, and an industry-changing tool, which is called EC3, which is Embodied Carbon Calculator. So I'll turn it over to Stacy to be able to review the EC3 and how it can be used. Thank you.
Thanks, Anita, and good morning or afternoon, everybody. My name is Stacy Smedley, as mentioned, and really, I think in both of my roles at Skanska, as well as building transparency, our goal is to reduce the carbon footprint of every building. And the question really is, how do we do that? I'm going to go into a little more detail when it comes to embodied carbon now, using the World Green Building Council's diagram out of their Bringing Embodied Carbon Upfront report, which you can all go find. And this is really just to ground everyone in the different stages of embodied carbon when we're talking about it and using different terms. The first stage is the A1 to A3 product stage. This is looking at the extraction emissions of getting materials out of the ground, extracting the raw materials, transporting them to a manufacturing facility, and then manufacturing those materials. So really cradle to gate manufacturing emissions. The next stage is the construction process stage. This is looking at the actual manufacturing of the transportation of the products from that gate to the construction site, as well as the installation emissions of the equipment on site. So that really is stage A, or what most people call upfront embodied carbon. And I apologize for my pug if you hear some snorting. That's not someone snoring, that's my dog. The next stage is the use stage, and this is really looking at replacement. So when you build a building, there are things that you might replace over time, replacing the carpet tiles or the ceiling tiles or the roofing membrane. And you have to account for those emissions in this use stage. How many times are you replacing them? And what are the emissions associated with that replacement? And then the last stage is the end of life stage, or stage C, which is looking at really how we deconstruct buildings, where those materials are going once they've been deconstructed, and how they're going back into new products, hopefully, as Anita mentioned, but may also be going to landfills where they're going to off gas in different ways. So all of these things together are embodied carbon. As you can see, there's different terms used: upfront carbon for the stage A. Even within the stage A, there's the product stage and the construction process stage. So really, it's how we look at this holistically for life cycle assessment, and then how we start to hone in on certain components of this in our work. The EC3 tool that Anita introduced is really focused on this product stage. It's the cradle to gate emissions. This is for a number of reasons. Most importantly, based on research done at Skanska and by a variety of others, this product stage really is the largest impact stage for most products, especially core and shell materials, but also even for products where you're replacing them over the course of a building's life. So if 80% plus of the emissions are in this product stage, we really want to try to tackle this immediately and urgently, and procure low carbon options for these materials and start incentivizing even lower carbon options to come to market. As Anita mentioned, for the product accounting, when it comes to life cycle assessment, there's also life cycle assessment for buildings. So this is where design teams are using tools that are looking at all of those embodied carbon stages, and also other greenhouse gas emissions besides carbon, and trying to make really smart decisions up front. So should I build a new building or retrofit an existing one? What are the differences on average? Should I right-size my building and reduce quantities of material? What system should I use for the structure or the envelope? These are all things that are really well informed by life cycle assessment, where we're using average emissions data to inform directional choices in design. The next step beyond that is, once you've made the choices about the materials you're going to use on a project, you're going to build the building out of concrete or steel or timber. You understand what your materials are from an envelope perspective. What we couldn't find prior to EC3's development was a tool that would allow us to look at those material categories and the products available and assess our specifications and procurement choices based on their carbon right alongside cost. And really, at the end of the day, both of these steps are necessary to truly realize embodied carbon reductions across your projects and across the industry. Just to ground everyone with the EC3 tool a little bit more, it is a free open access tool. It started as a project of the Carbon Leadership Forum, conceived of by Skanska Sea Change Lab, and it was funded and continues to be funded by an ecosystem of over 50 industry partners that are giving their time and their support to maintain EC3 as a free open access tool with an open, transparent database available through an API. Building Transparency was established to continue the management and execution of the tool as a nonprofit, so we can continue to take support from industry as well as philanthropic funding, and anyone can now go register for the tool at buildingtransparency.org. I encourage you to do so. What EC3 is doing is not rocket science. It's similar to what we do with cost estimating. We take material quantities and we multiply them by that stage 801 to A3 embodied carbon emissions data in kilograms of CO2. And we base our data on a digital EPD database where you can actually pull EPD data into collections and specifics to do product by product comparisons, but also to create building upfront estimates of embodied carbon based on the supply chain, the ability to set reductions, and then actually realize savings based on the EPDs selected. Again, we are using third-party verified environmental product declarations. These are the documents that Anita mentioned that can become very long, lengthy PDFs. So our tool is currently digitizing those PDFs into a digital EPD, or we are trying to interface through APIs with certain program operators that are already digitizing those EPDs. That's really limited to concrete right now. What you're seeing here is an example of that little chart that we're trying to find within that PDF document that's giving you a declared unit, which is similar to a serving size on a nutrition label for a food item, and a kilograms of CO2 per unit, which is similar to something like carbohydrates. So an EPD, when you're finding this information, is really very similar to a nutrition label for a product. The next step is just how the EC3 tool works. Once you're logged in, you're going to come to a screen that allows you to do a number of things. The first is find and compare materials. You're seeing here a list of all the materials currently in the tool. If you see pilot by the material category, that's because that material category is currently being assessed for variability as well as baselines and is not currently in the public version. They will be coming soon. So taking an example of concrete, where we've gone into ready-mix concrete, we've filtered by what we would like to look at. I'm looking at a regional collection right now, just to understand the EPDs in that region. And then it will return your results. So this is looking at 2,000 samples since I've clicked that search button. It's going to return this box plot diagram for any search that you do based on your requirements. What we're doing in this box plot diagram is very important. You're first going to get the results for the number of EPDs that return in your search parameters. You're going to see the highest return results in a kilogram of CO2 per unit. You're going to see the lowest return results, and then this green area is vitally important. It's the 20th to 80th percentile. So that's where 60% of the data lives. There's 20% below that's achievable, 20% above the conservative. The last line that is important to understand is the CLF baseline. This is something that was created with the Carbon Leadership Forum as a partner for each material category, and you can access the document by clicking on that line within the tool. Just to remind everyone, a baseline is supposed to be a line serving as a basis, a boundary line at either end, and a starting point. And really the high conservative baseline is in the tool to really let people actually start to make reductions against a set target that's static and published. If you think about this alongside Energy Code and ASHRAE, baselines can be updated and get better. So we're hoping that through setting a baseline and incentivizing disclosure, over time that baseline will get lower as materials begin to populate the database and manufacturers continue to create lower carbon options. Going a step further, once you've already decided who your manufacturer is and you know maybe where the plant is for concrete, what they're going to be sourcing their mixes from, you can do this for any product really. So if this was carpet or ceiling tiles, you'd be able to select the products in this list. You can select up to 8 and then click on compare and start to understand next to each other the comparative embodied carbon emissions per product or mix. If you click on the view button next to the EPD in that search, you'll be able to go to the digitized version of that EPD, download the PDF for reference, get some key information that we've digitized out of the EPD, as well as understand the burden of the doubt or the relative accuracy of the data. So you'll see here there's variability factors set for manufacturer, plant, or product specific data, as well as supply chain specific. So for something like a concrete mix, you'll see here there's that blue squishy stuff around the declared value in the middle on this EPD. If we got cement plant specific EPDs, which are starting to come to market, we could be 90% supply chain specific, and that variability would go down to 0 because we had actual plant specific data. You can also import EPDs. So if you are registered in the tool and you have environmental product declarations that are currently not in the database, you can actually click on the Import EPDs button and add up to 25 PDFs of EPDs at a time. You'll be able to understand if they are duplicates already in the tool, where they are in our digitization process, and if we were successful in actually creating the digital version. We really are based on this EPD database. We are an ecosystem, and we are gathering EPDs from all sorts of different sources, and we are only as good as the EPDs we have in the tool. You're seeing here that for concrete, because we do have that digital API, we are able to get mix-specific EPDs in real time from concrete suppliers that are invested in the process. We are hoping that this will incentivize other material categories to also look at their program operators to digitize EPDs, as well as get more product-specific and plant-specific EPDs so we can make more accurate assessments. The last thing I'll walk through is just how we create a project in the tool using this data. We can actually get materials quantities from multiple sources. The first is just an estimate from a contractor where the information can be put in by hand. This takes someone at Skanska about an hour or two to complete. We can import from BIM 360, or we can actually click a button, log into your Autodesk account, and bring in a BIM model with the material quantities attached. Or if you're doing a lifecycle assessment using Tally and Revit, you can actually open your project in EC3 and have the bill of materials translated into the EC3 project planner. Once you go to Plan and Compare Buildings, this is where you can create a project. You'll see here, here's the Add Building Project or Import from BIM 360 button. Once you've started a project, what you're going to do is either have this auto-populated through your import or hand-entered from your estimate. You're going to put in your quantity information, either metric or imperial units. The tool does the conversions for you, and you're going to complete those searches specific to your project within the planner. You'll see here that I now know more about my mix, so I'm putting in 5,000 PSI and a 100-mile radius to get to suppliers I would actually use for my project. I'm then using this collection to give me that range of conservative and achievable for my project. This is happening at about 100% DD. Once you do that, it's going to start looking at total embodied carbon from your project, both the conservative, achievable, and realized. The realized defaults to the conservative until you've actually selected your environmental product declarations. If you view the GWP summary at this stage, you're going to see that I've set a target, and I've also put in my quantities and my search collections. It's telling me relatively for each material category on the left, the scale of impact of that category, and in the white for each material category, the available reduction based on the current supply chain collection of EPDs we have in the tool. This rolls up to the different components of my building, all the way up to the right to get an achievable savings target for the overall project of 43% against the CLF baseline. The next feature, which is new, is the ability to look at embodied versus operating in the tool. So once you put in your information and you even have a baseline to start from, you can start to look at the comparative analysis. If you click this open, you can put in your proposed EUI, you can put in your mix of natural gas to electricity, and you can, from the drop-down menus, pick your actual energy profiles that you'd like to use. If you click the view button, this is looking for a project in Seattle where we have a largely hydro grid and a low EUI for the project. We'll show you the comparative analysis of embodied versus operating carbon to 2050. So just for a second, really the steps right now when you're trying to use EC3 in a process flow, first is to check for EPDs and see if the manufacturers or products have them in the tool already. If they don't, if you can't source them, the first step is to ask for them. If you go to buildingtransparency.org and click on resources, we have downloads available for EPD request letters that could actually be standardized for your ask for your project team or your firm. We are wanting folks to use these so that manufacturers are getting multiple standardized asks for the same thing. And we're also already seeing this work with adoption of EPDs for concrete in places like Arizona. If the manufacturers or products do have EPDs, specify them. So use the tool to look at your products comparatively next to each other. Understand if you can start building in language about EPDs, EC3 limits, CLF baselines, product GWPs, all these things into your specs. We are currently also working on a downloadable spec template for material category. So that should be coming soon. The next step is, once you've done that and specify it, you have to make sure the request makes it into your bid document. So ensuring that your contractor is on board. There is also standardized bid language on the Downloads tab on Building Transparency, where you can start to look at standard language for your bids, requesting EPDs, asking suppliers to invest in them if they do not have them, and explaining why this is important. This is an example on a project where concrete was using this, those bid templates. We actually got a performance requirement spec from our structural engineer. We're able to request EPDs from our suppliers because we're lucky in Washington to have multiple suppliers already with EPDs. And we were telling them that we were looking at cost and carbon. This is our leveling sheet where we actually have the CLF baseline and the regional benchmark for from NRMCA, and are able to see at the bottom the reductions against those two numbers. We look at this alongside cost, and in this case, the low bidder was also the low emitter. So we were able to achieve a 30% plus reduction against the NRMCA regional benchmark and a 50% reduction against the CLF baseline. The next step, of course, once you procure, is to actually realize the savings. So similar to how we would verify other impacts of things for things like LEED, If you know your manufacturers and you have your EPDs, you can go back into your searches and select the EPD that you actually use. And what that will do is allow you to use the selected versus baseline button to realize your savings. This is showing the overall building total and reduction on the left, looking at CLF baseline versus achievable target versus realized savings. Of course, on this example, I picked the best of everything and how that actually breaks down per material category. This also maps the LEED 4.1 procurement pilot credit, which gets you up to 2 points in the innovation category for assessing things based on the methodologies established by the CLF and reporting for the public categories in EC3. And with that, I'll turn it over to Kirsten to talk about a case study of a project where she's implemented embodied carbon reduction. And I again apologize for my dog. I hope he wasn't too loud.
Thanks so much, Stacy. And good day to you all, wherever you happen to be. I'm Kirsten Ritchie. I'm principal here at Gensler, and I'm also director of sustainable design. Some of you may be aware, but Gensler actually announced last year our kind of climate change commitment, and that basically we're looking to eliminate all greenhouse gases associated with the built environment. Traditionally, that had been kind of really focused more on the issues associated with sea level rise, associated with melting glaciers. But we've really learned more and more and more that there is such a close nexus between climate change and health. This is part of a campaign that we did for UCSF, where they've basically come out and said, we know climate change is affecting everything, whether it's causing increased, asthma, heat stress, all kinds of air pollution issues, and then of course we have environmental justice associated with that. That we need to double, triple, quadruple down on doing what we can as design and construction professionals to really get carbon out of our built environment, because it points to climate change, and climate change affects everything, again, including health. In terms of kind of giving you a little bit more proof, there was a project that we worked on. This is a big project actually for SFO, where we started to do sustainable return on investment. And it's a methodology that I would encourage many of you to be looking at for larger projects. But this is where you actually start to economize or put dollar values on kind of social and environmental aspects of activities that you're doing when you're designing and building projects. And we're able to do that really looking and honing in what is the value, what is the societal value for us to reduce the carbon footprint of the materials that we're putting into our building, or actually reduce the overall carbon footprint of the building we're designing. And we estimated it cost us about $100,000. This is $1 billion construction project. So $100,000 that we spent, and it really is not on increased cost of materials. It's basically doing the research to identify the right things, whether it's the right concrete mix design, the right supply chain for your steel, to actually source lower carbon materials. And we found with that $100,000 investment that we basically return a societal benefit of over $12 million. And that's a lot associated with really kind of improved health conditions, right? You have less carbon in the air, you have less asthma, you have less allergens, you have less heat stress, illness associated with that, and you're able to quantify that. That basically means for that investment, we delivered a benefit cost ratio to society of over 129. Anything over 1 is great. So, or it's good. So, 129 by kind of benefit cost ratio, these are the kind of things that you're really looking forward to do. So it's just reinforcing over and over and over again the value of us as leading design to really seek out, work with our manufacturers, work with the supply chain to build our projects using lower carbon alternatives. And as we talked about, or as was mentioned by both Stacy and Anita, that we've learned, we've always had traditionally been much more focused on the operating side of things. But as our grids get better, as they get cleaner, as we're using less energy, the footprint and the long-term carbon impacts associated with the stuff that we use to build our buildings, really it basically almost equalizes what the emissions that are associated with the actual operation. And we're now finding, like for every new building that's built over the next 30 years, that in essence, the embodied carbon footprint will be equivalent to the operating carbon footprint over the 30 years. And we really expect that this is going to be reducing over time. And again, back to the design points of view, your impacts, our impacts are right now. If you look, you see this big tall bar, practical completion. This is kind of the trend of embodied and operational carbon over a project's 60-year life. And you can see how much from the embodied carbon perspective, it's right here, it's right now, it's what you're doing, it's what you're choosing, it's what you're building right now. And then we have, of course, the operational emissions continue as the project, starts to operate. And then we have, as mentioned before, during replacement and maintenance, we add more materials. And so we increase the footprint associated with embodied carbon. And then we also have to address it at the end of life if we've not designed these materials to be reused or to find their way back into production. Or successful production. But getting back, really focus in and say, it's all on us right now to do something about the embodied carbon footprint of the stuff that we're designing, that we're building. We did a case study. This was just completed last year. This is actually for a small a tenant improvement, only 10,000 square feet, so kind of small. And we did a baseline design using the available information at that point in time, mostly EPDs that we had gotten from manufacturers, as well as some EC3 was coming out. We were starting to be able to use that. But we did the baseline design. We said, okay, what is the carbon footprint of this project using industry averages? And you see here, we found that this small project had a footprint of over almost 11 pounds of CO2 equivalent per square foot, 43,000 kilograms total. By being smart and saying, okay, what can we do? We were able to reduce the footprint, and this is just a 10,000 square foot project, small, a really tiny little budget, over 43%. Just being smart, and it's really understanding kind of the understanding where the footprint is on your different materials. If you notice, for example, the big difference we made in carpet, and I'll show you in a couple slides that, this really, the range of footprint that is there in the world of carpet is pretty astounding. But carpet, steel studs, not able to do that much too. Wallboard, we were able to make some difference. Glass, this is storefronts that are actually, storefronts that are on the different offices. And then, ceiling. Ceiling was another area where we were able to make a difference too. I have to say, one of the things that surprised me was paint. It's like, wait a minute, how could paint have a carbon footprint? But it is a polymer, it's a plastic material, and it has a footprint, and you need to be paying attention to it. But again, this is just, pretty straight, kind of easy moves, no cost increase, no effect to schedule, and you're able to reduce the footprint, 42%, and more, you can bring that down. So we took that information and we're now starting to apply to other projects. And this is for actually a project that's currently ongoing right now, where we started to look at, this is a rather large adaptive reuse project. And our design team is quite large, and they're very interested. And they said, we really want to do this with the right thing from an embodied carbon perspective. And it was great because the design team wants to do it and the client wants to do it too. But I want to enforce that regardless of what the client says, you should just be doing this, and be smart about the materials. That's fine. So you see what was really interesting. What we did, we plotted. This has all been normalized. This is the A1 to A3 embodied carbon footprint of these materials, all expressed as kilograms of CO2 per meter squared of surface area that they cover. And it's really surprising the range. This first category up here, this top, the first colored line. You see, the range goes basically from almost 0 to over 20 to 25. That is a 5x or a 500% delta between the best performing, i.e. lowest carbon product, and the worst, which has the highest carbon footprint. That's just, it's a huge range, 500%. Think about that. That's huge. And so we can be smart as designers, be smart, know who's having the footprint, and specify them. What we also have done is we've kind of tried to triage, and we basically have identified basically through the quantities of products that actually have EPDs, get their information, and said, this represents the best kind of third, which we reflect as green. And then you have kind of average, which is yellow, and then you have really, these are high, and high being negative in this situation. They have a high footprint. So, what we're also encouraging our design teams, because many of them say, it may have a high footprint, but I love it. But work with the manufacturer, work with the supply chain to say, okay, explain to us why this has such a high footprint, and what are you doing about it to help to bring it down? Because eventually we're thinking that a lot of the, all come together, and we're going to be more like we have down here with our metal systems, where the range is pretty tight, and so there's there's not so much in terms of optimizing. But the other categories I wanted to bring out to your attention, where you also look at the next kind of green bar from the top, or the colored bar, is insulation. Again, big range in its footprint. The same with drywall. I mean, a drywall is also really surprising. You still have, it's not 500%, but it's still almost 300% difference between the lowest footprint and the highest footprint. And I should say these are all equal performing. We're not compromising on performance. Green products are not high performing. I mean, if it's not high performing, it's not a green product. So just wanted to bring that to your attention. Then we have also like ceiling finishes. You look at the range, and again, this was thinking ceilings. Like, who would think that there would be such a delta? But there is, and so it's really important again to understand that. The same applies to both non-carpet or resilient flooring and carpet, and then also even drywall. So, or plywood. So all of these things, and it's really, as you're starting to get this information, and it's now so available through the great EC3 database, through manufacturers, really, kind of investing in doing LCA and doing their environmental product declarations, that we're getting this information out and really starting to be able to take action. So, just asking what you want to do to start today. That you figure out, kind of look and say, okay, categories, what's the stuff that I focus on? And start to then establish some baselines, get some information, go through to EC3 to get the information, talk with the manufacturers, look at all the different ranges and the opportunities, design and specify, and then the important thing is to procure it. So working through the whole kind of construction chain to make sure that the products you're specifying are actually being procured and installed, and then track and verify, making sure that things are really doing well. In terms of establishing categories, I just say you look at the things that you specify the most. You look at the things that really you're buying the most of. If it's one little cast chair, don't need to spend a lot of time on it. But if you are installing 20,000, 25,000 square feet of ceiling tile, yeah, you want to you want to learn and understand the footprint or the range of products and the footprints associated with those that are available to you. But I do want to specify, state, if you don't specify, you're not going to get it. It's really important that you follow through. And whether you do that on your plan and as a plan spec, or whether it's actually, in a separate project manual. And the first thing to do is say, we want an EPD, because your design, you're basing on certain assumptions, but you need to have the manufacturer provide the specific EPD for the product that gets installed, and that's relative to current production. But it's so important to do this, and you should just, make sure your specifications are all updated right now to say, we're just, we're asking for EPDs. And you can even, say we're providing incentives for it. Like in some cases, we say that you have to, that we will be choosing products that have a lower carbon footprint, and that, so therefore it's an incentive for the manufacturer to include it. But I can't understate the value and importance of making sure that you specify it. So, in conclusion, wanting to say, we'd like to have you all think about what are the things that you can do as practitioners in the built space to really make a difference, to help us reduce the carbon footprint of all the buildings and all the interiors and all the spaces and places that we are designing and impacting. So, again, hone in, focus right now on acting on embodied carbon. Learn it. It's a new vocabulary. It's an additional kind of a variable that many of you may have not really looked at before. And so you're going to have to teach yourself about that. But again, you can go to EC3 or you can go to Materials Can, and there's, videos and tutorials and all that kind of stuff to help teach you about embodied carbon. Demand embodied carbon transparency via the whole EPD process. All your manufacturers, talk to the sales reps. Get yourself comfortable with the EPD language, and then talk with the sales reps to get them to do it. The manufacturers are keen to provide this information, but they want to know that you want it. And so, that's, again, get that word out. Start to make some of your purchasing decisions based on the embodied carbon footprint. You may love a product, but it may not be performing well at all. And you're going to have to say, I'm going to work with you, Mr. Manufacturer, but you need to get it down. And in the meantime, I'm going to be using another product, just because it is so important that we that we minimize the carbon that we're releasing as part of our design projects. Ask that you support embodied carbon research and data and tools. You can join up you can join the Carbon Leadership Forum. There's a number of different organizations if you want to, to participate in that, to really help us get more information out and make, get tools out, make it easier for us to all find and specify low carbon, high performing, beautiful products for our project. And, sure, it'd be great if you want to become an embodied carbon leader and really take, get on that bandwagon. We'd love to join us. So, again, these are things that you should do. And then basically what it's going to, the results that will be, you're going to help to incentivize low carbon material and products. You're going to have it become the norm, we really hope. And so that, that we're encouraging and we're working with the manufacturing and supply chain to always be striving for lower carbon embodied materials. We want to drive market innovation and investment. Again, it's like, I got this far and I don't have to do anything more. It's like, no, we're looking for continuous improvement, continuous innovation, new ways of getting to low carbon environments. And then also helping us to deliver to the marketplace better quality data and tools, the data and tools in the form that you are all interested and really want to have. So that gets us to the whole idea that working together, we really can deliver on beautiful, functional, high-performing, but decarbonized places and spaces. And with that, I'm going to turn it over to Dean, so we can now move to Q&A.
All right, terrific. Thank you, Kirsten, and thank you, Stacy and Anita. We are in the question period, but before we start our presenters addressing some of these questions, I just want to remind you that we do have a survey that we'll be submitting out, and if you could give us your feedback, that would be terrific. And now go to the questions. Okay, so we've gotten a lot of questions in on this because a lot of ground was covered very quickly. But the first one that comes in from many people have been asking, what is the embodied carbon of Stacy's dog? No, only kidding. Stacy, you don't have to answer that question. I think we all have a good feel for that. So first of all, starting maybe with you, Kirsten, and the second part of the presentation, really. One question came in that said, are we trying to reduce embodied carbon just by looking at specs and product environmental declarations? There's other important information being given, but it's in a compressed time period. And one that sort of goes along with that, most of the presentation focuses on hold on a second, a better one up here. When we're moving some of these high carbon footprint materials through the comparison you can do with EC3 or via the system that you're using, Kirsten, like plywood, ceilings, et cetera, what are they then being replaced with? Is it better performing versions of the same product, or is it sometimes a different product with a better EPD? So that maybe, Kirsten, you could start with that, and then.
Yeah, sure. And it's a combination of everything. So you're looking at, and Stacy alluded to it a little bit earlier too, the whole idea like the tools with Athena and Tally, where you're actually looking at different building systems, that are have different carbon profiles. For example, are you going to do concrete, steel, or a mass timber building, right? That has variations as well. I think it really depends on the scale. The easiest thing, and I always just like to get people started. And so the easiest thing is if you look from an interiors perspective to say, I know I'm going to be putting carpet down here. I should be hunting down and trying to find that meets all my performance specs, but is lowest carbon. And so, kind of easy, straightforward thing. The next thing, but then you have the other questions of like, well, should I even have carpet? Should I put, have something else? One thing I do want to highlight for folks, a lot of people say, oh, well, I don't, I'm going to put down carpet, but it means I'm going to have to top up my concrete slab. And so, but that, doesn't take very much cement to do that, so it should not be a problem. Topping cements, are hugely carbon intensive, just to let you know. So you don't go ahead and just make that assumption. The other thing too, like you're looking at ceilings. Should I be putting in ceiling tiles, or can I leave the ceiling open, right? And so that affects the aesthetics, it affects the acoustics, maybe your ventilation patterns. You have to make that decision. So but that would be the trade-off thing. I can avoid a footprint of ceiling tiles. Not that Anita wants me to tell you that. By not installing them, but I do have to think of the other ramifications. So, it's one of the big things too. We always were talking about going open plan. The beauty of an open plan environment, it actually has a much lower carbon footprint, because you don't have all the walls. Wallboard is a pretty intensive product from a carbon footprint perspective. So that's one of the trade-offs. How many walls do I have versus not? But again, it affects the environment. So you think, there's all those different things come into play. But start, depending on where you are, start with, kind of some of the easy steps. And that is like, I'm already installing this. Let me find the best performing, lowest carbon footprint alternatives that I can specify that.
Okay, yeah, and I'll just add to that, I think, I would like to add to that, I think, generally just about, what EC3 does with EPDs and what the other things you're doing from a comparison perspective. The challenge right now is that, it's not a challenge. I think it's just, there's two kind of different ways of looking at things. EPDs are very specific to their material category when it comes to the rules in place. And it's really not good. They're not comparable when you're taking, a concrete EPD and comparing it to a steel EPD in terms of what they're setting up for the rules of what they're including and what that kind of PCR product category rule language is. So really with EPD specifically, right now they're best at comparing within a material category to get to the lowest carbon option. And if we do that and we start to incentivize lower carbon options, what that does is the average emissions factors that are being used in whole building LCA tools, where you're taking just one number for carpet and one number for another flooring type and be able to directly compare based on average data, those numbers will go down because the industry numbers are going down. So it's cyclical. I think we need to do both. There's really good LCA tools, like I mentioned, for those average choices of material category versus material category early in design. But there's low-hanging fruit right now when it comes to what we can do from a specification and procurement perspective. And if we do that, we are going to lower the carbon of the materials that we build with.
Well, so let's maybe, there's a couple of questions that have come in that sort of are related to that and to the EPDs. And so if we're comparing within categories and within concrete, or pick a category, whichever makes sense to you, what's an example of what would drive the difference between a low carbon EPD? Can you just give an example of the kind of, either, is it in the manufacturing, is it in the materials used, is it in the mix of materials, all of the above?
Yeah,
and how is that, just an idea of what drives that?
It's very material category specific, right? It changes whether you're looking at concrete, where it really is the percentage of cement versus replacement, or carpet, where it might be the backing, the manufacturing of the backing, and how much recycled content or what that's made out of in terms of the backing material. So every material category has a different kind of pressure point when it comes to the highest impact. For concrete, it is the cement. So that's why getting those cement plant-specific EPDs is so important. So if it is going to use cement, we're hoping we're getting the lowest carbon cement, and then we can look for EPDs that are actually for mixes that have a higher SCM content. For something like carpet, it is, we work with Interface a lot. Their part of materials can. It really is looking at the backing, and can that backing become something that's 100% recycled or that's made out of a biomaterial to get the carbon content of that carpet tile down. So it really is, we have to get educated as an industry about what we're asking for, but the EPDs give us that result. And so the investment in actual innovation and research on the manufacturer side is where they can start to look at those alternatives to the higher emitting impacts of their product.
Okay.
Yeah, and I'll jump
sorry, go ahead.
Yeah, I'll jump in. This is Anita. Just from sharing from a ceiling product category standpoint, it's also recycled content. So materials that can come back at end of life through a recycling program that helps us to offset the virgin raw materials in that important stages of A1 through A3 that Stacy had shown from the tool. So by using more recycled content in the raw materials, that helps to offset the carbon. So that is good, as well as the energy, as well as using less water. So it's all about those raw materials in the manufacturing stage in terms of our product category.
Okay, so thanks, Anita. Sort of following on to this about concrete, just taking a little step farther, a question came in about, typically concrete will have reinforcing steel in it. How does one, whether it's the EC3 tool or the whole process here of trying to think about carbon, how does that work with with products that are mixes of product types? And then when you're starting to trade off one potentially better cement mix from an EPD perspective, but doesn't have the strength or setup characteristics of another one that's worse, and you really get into it with a wall and how it's constructed, how do you begin to thread that needle and navigate your way through that kind of situation?
Yeah, so first on the concrete versus the concrete reinforcing,
yeah,
which are separate. So in the tool, you can actually search for your concrete mixes and you can search for your reinforcing materials. And there are a lot of actual rebar EPDs in the tool that you can utilize to pick where you're going to procure that rebar from. They're different procurement streams, therefore they're both something that you're able to assess and reduce. Similar to curtain wall, where you're looking at glazing and aluminum. There are curtain wall EPDs, but really it's much better to get a glass EPD from your glazing supplier and an aluminum EPD for those materials and bring them together to look at those kind of systems. The second part of the question about concrete specifically, that really gets into when you start this process. And, I think this is the one time when structural engineers are really vitally important to sustainability in buildings. They've been kind of on the sidelines. We're talking about other things that we've been looking at for a long time. But engaging the structural engineers to understand where we can take longer to get to strength, or where we can just give a performance spec that says, okay, yes, we do need this to be this strength by this day. Give us your lowest emitting option. It's something that can happen during the design phase to inform the specs, and then something that you can analyze during procurement and even after procurement when you have your supplier on board to say, okay, we now know we can optimize this location and get to strength in 52 days or whatever that might be in terms of 28. So it just really depends on, I think, the most important thing is involving everyone early with their perspectives, and really for concrete, it's performance-based specs where you're not pigeonholing the concrete suppliers into certain replacements. You're just giving them the things that cannot be changed from a performance or schedule perspective.
Yeah, and I think
okay.
to kind of
go ahead.
To pile in on top of that, it is really the importance also of looking at more of our specifications and drive them to more performance-based versus, what we typically say is, okay, here's my basis of design product, and use it or equal, and we haven't defined what that equal really means to us. Or the issue with concrete, you'll see so many times the concrete specs, it's not performance, it's just mixed design, and which really limits your ability to come up with alternatives that meet the same performance in terms of speed to strength hardening, all the kind of key factors that you're looking at, but that where you could achieve those many different ways in terms of how you're where your aggregate's coming from, where your the cement ratio compared to other polymer materials. So really looking at that, saying, am I being too prescriptive in what I'm asking for, and therefore I really need to be more performance based because it's going to enable me to get what I want, but with a lower carbon alternative.
Terrific. Okay. Just sticking with the EC3 tool, so we don't have too much time left, but a couple of questions came in. Where do you register for it? And also, how mature currently is the EPD database as a measure for architects? I think it was indicated that across some products it's fairly robust and others it's not, but maybe you could answer both of those. Where do you register and how robust is the database right now?
Sure, yeah. If you go to buildingtransparency.org, there's a register for free button that you click, and it asks for your name and email address and password you want to use, and that automatically sends you a link to log in. So it's a pretty quick, easy process. You just need to go to buildingtransparency.org to do that. So currently there are 9 public material categories that we launched in November that we're really looking at core and shell and major envelope, and then a couple of interior materials. That's what the public sees. On one of those slides, I was showing all the pilot categories that include things like waterproofing, roofing membranes, cladding, other flooring materials, more wood categories. All those things are coming. Currently, the EPD database is actually populated with all those categories, and we're waiting to set the CLF baselines and the variability that we use to release those publicly, as well as have manufacturers from each material category help us on the kind of searching and sorting for that category. So the pilot users that are funding the tool and meeting with us and understand that some categories are mature and some aren't have access to all of those things. Public users have access to the public categories. We're hoping for a November release of those additional categories.
Okay, and maybe one last question about the EC3. Who can submit an EPD? Does it have to be a manufacturer, or can it be anyone who is registered to use the tool?
Anyone who's registered to use the tool can use that import EPDs function to upload them. We verify that they are valid based on their expiration dates and the program operators. So That's on building transparency in our relationships with program operators to ensure that they are not, no one's punking the system and trying to upload something that's not real. But yes, we are crowdsourced, so please, anyone using the tool, please update EPDs if they're not currently there.
Terrific. Okay. Well, unfortunately, I think we're closing in on the end of our hour, and so that will be the last question for today. Please join me, everybody, in the webinar in thanking Anita Snader, Stacy Smedley, and Kirsten Ritchie for their presentations and for the interesting answers they've had to these questions, as well as our sponsor, Armstrong. If you have any additional questions or comments, please don't hesitate to click the email us button on the console, and please visit architecturalrecord.com/webinars for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you found this webinar to be a valuable experience, and we wish you well for the rest of the day. Thank you.